Now for the input waveform, we are getting the output like such till the cut-in voltage output will 0. After that, as input increases, output will also goes on increasing. So output will be proportional to the input. Again, when it's going back towards the 0, the transistor will get cut off when the input voltage is less than the VBE cut-in, and we are getting the 0 output voltage here. And again in the negative cycle, output will follow the input, and till input is greater than VBE cut-in, and after that we are getting the 0 output. If you observe carefully, we will find that portion which is near the 0 crossing, we are getting the 0 output, and hence this kind of the distortion we are calling it as a 0 crossover distortion. Main reason for this distortion is the class B operation. Here, as we know that in the class B amplifier, we are having the operating point at a x-axis, and hence the 0 current flows through a transistor when input signal is equal to 0, and transistor will not be able to conduct whenever the input voltage is less than the VBE cut-in, and hence we are getting the output 0 proportional to the portion of the input signal which is less than the VBE cut-in value. In order to overcome this particular problem, we will be able to propose a class AB amplifier. In the class AB amplifier, we are going to put an operating point just above the x-axis, so that continuously the current will be flowing through a transistor, but very small value of the current will be there definitely, so that the transistor will be there always conducting even if the input signal voltage is equal to 0, that is applied to the transistor. We will see now the class AB amplifier, whose characteristics will be as shown here in the figure. The operating point is just above the x-axis, and we will be able to represent it like this. This is the Q point in class AB amplifier, and hence we are getting the minimum that potential will be always available across the base to emitter junction of the transistor, so that even if the 0 amplitude input signal is applied, we will be able to get the output that will be proportional to the applied input, so that we will be able to write down here the waveform for the input signal. During the positive half cycle, we applied as the transistor is already turned on, even if the input signal is equal to 0, we will be able to get the output is following the input as it is here during the first half cycle. Whereas for the second half cycle, in the negative half cycle, another transistor is there, to which we have the operating point will be like this. We have the load characteristics for the second transistor we can have, and we will be able to mark down the operating point just here, so that we will be able to have the another input cycle which is a negative. There we will be able to get the output voltage waveform, which will be as shown here by the blue line, and we can see effectively as during the 0 crossing there is no distortion present, as the one of the transistor gets turned on while pushing the another transistor to off condition, and hence the smooth transition will take place, and we will be able to remove the crossover distortion from the given amplifier.